from Earth. It's Space Radio. This is Paul Sutter, and coming up, we're talking about who wants to visit the moon anyway, and you can't see in space. And of course, taking listener questions about all things in the universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about a book deal of the century. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. Got an exciting show for you today on Space Radio, where we talk about all the things in the universe. Surprising. A lot of topics, not a lot of time. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708. Light it up. Get those calls in, and we'll have a nice little chat. You can also follow along on our live streams. Join with the other space cadets over on YouTube and Twitch. Go to spaceradioshow.com for the links. We'll take questions that you send there too. Seriously, folks, I've only prepped 10 minutes to show material tops, so get those calls in. How's it going, live streamers, space cadets? You can tell I'm somewhere different. Arnold Post, you saw me in a movie, you saw me in a UFO. That was so cool. I had lines, I swear I had lines, but they got cut in the final edit. That was so... I'm not bitter about it because the director has to make a good movie. That's the director's job. And apparently a good movie didn't include my lines. But instead, I did a good job. I'm obviously not in studio, so I have to do all my own producing. Before I start taking calls, I wanted to share some interesting bits of news I caught recently. And first, it's so good to be back on the air after that brief hiatus due to wonderful, wonderful oral surgery where I was mushy and mumbly mouth more than usual for the past couple weeks. I was basically talking like this. I could barely even make sense to anyone. And I tried to record a show. Greg said it was my best work ever, but I'm pretty sure he's just trying to undermine me so the show gets canceled. So I didn't trust him. So instead I took a break, and we are not taking calls today because even though the hiatus is over, we are back on the air. I am not in Columbus, Ohio right now. In fact, I'm down in Cocoa Beach near Cape Canaveral, the Space Coast itself. And I'm getting ready tomorrow to lead a tour of the Kennedy Space Center and then lead a stargazing tour of the Caribbean, where we'll be sailing across beautiful seas and beautiful lands, looking up the skies every night and visiting very cool, very ancient Mayan ruins, some of which have astronomical significance on our little astro tour. So it's an amazing trip, and I'm lucky that I have my nice little microphone here so I can still record Space Radio and get some cool news out to you. And what I wanted to talk about today was this announcement by Elon Musk of the first official SpaceX tour. So I'm sure there's been a lot of unofficial SpaceX tours of like, yeah, I'd like to go to Mars. Where do I sign up, Elon? No. This is a real space tourist that is paying real dollars to go in a real spacecraft to visit the real moon. They're not going to land on the moon. That's somewhat challenging. Instead, the plan is in 2023, a Japanese fashion innovator. Apparently, you make lots of money as a fashion innovator. An art curator, Yusaku Maezawa, who apparently has tons of money and nothing better to do in the year 2023, is going to be launched in a rocket known as the BFR, or Big Falcon rocket, the Big Falcon rocket. It's going to send him up into space. This is the plan. Go to the moon, loop-de-loop around the moon, so he gets some pictures and stuff, and then come back to Earth. and live throughout the whole thing. That's actually the difficult part, is actually making it back down onto the ground safely. And Yusaku doesn't want to go make the trip alone. He wants to bring a posse of artists and dancers and photographers and painters and poets to go on the trip with him. And so they get to see the moon, they get to see the earth from very, very far away, and they express it creatively as artists are wont to do. And I think that's super awesome. I actually think that's really cool. You know, I have a passion for science and the arts. Yusaku, if you need like an actual scientist who knows how to talk to artists, give me a call. That's 888-581-0708. Not only will I get you on the air on Space Radio, I will accept your invitation to visit the moon and see it up close. Now, will he actually get there? Will this rocket, which doesn't exist yet, will it actually launch in 5 years? Who knows? Will it actually be as expensive as Elon Musk claims it? You know, there's so many unknowns. It's a cool announcement. There's a lot of press. There's a lot of hubbub. Will it turn into reality? Well, let's check back in 5 years. That's the latest and greatest when it comes to space. It's time to have a conversation. All right, Space Cadets, I need some questions to fill in this episode because I'm not taking callers, but I do have a voicemail that I am going to play, but I need some questions. What are you curious about? Potapom, no, I don't think you're allowed to go to the moon. Yes, that's right, Alexander. In the movie, I did get credited as male astrophysicist because it was a legit role. I had to audition and everything. I got paid union scale to do my lines, and it was a credited role. I also happened to be a male astrophysicist, so it worked out really well. I didn't even have to act. I just showed up and was myself. Raj, I actually don't know too much about the new BFR design, but I'll talk about it. But yeah, get those questions in. Put the big blue question mark if you can. That helps me pick it out in the chat. Titan. Oh, yeah. Let's talk about Titan. Titan. I love Titan. We can talk about Titan. And I can also talk about the other bit of news, which was you can't see in space. All right. Next section. Man, and I see it, and I see all of you calling in, and I'm very sorry. I can't take the calls right now because I don't have that little bit of software set up right now. I didn't think anyone would call, and 2 people have called. We've got questions lined up from the Space Cadets right away, asking over on YouTube, Raj Luthra, asking about the thoughts on this big Falcon rocket design. For those of you who don't know, even if we decided as a society, as a country, as a world, like, hey, you know what? Mars is pretty awesome. We've been talking about it for a while. Let's all go to Mars, like tomorrow. We couldn't. We couldn't go to Mars. We do not have a rocket powerful enough to send a human being with all the stuff that a human being needs to Mars. We used to. The Apollo program, those rockets were big enough, were powerful enough to send people and stuff to Mars. But then we stopped making those. We made a bunch of smaller rockets. We didn't make the big ones anymore. And it's been a few decades and we kind of sort of forgot how to make the big ones. So now we have to go back to the drawing board and do big ones again. The big Falcon rocket, BFR, being designed under development by SpaceX, the private company right now, will be even bigger than the Apollo rockets. That is a giant piece of engineering. And it's not going to be multi-stage. Usually big rockets like this will have 3 separate parts where a big booster gets you off the ground, and then that detaches, and then a second booster gets you a little bit higher, and that detaches, and the next booster gets you even a little bit higher. It's just going to be 2 parts, a big old rocket, a big Falcon rocket, and to get you up into space, and then another piece that's the actual spacecraft that will fly you around wherever you want to go. But because that spacecraft is so large, it's very heavy. So it's very, very difficult to get something into orbit out of the Earth's atmosphere and then get that thing further onto the solar system. You need to use all your fuel, all your energy just to break our gravity well. That itself is incredibly challenging. So the design, the expectation of this BFR system is that there will be fuel depots already in orbit. That series of previous launches will have tanks, fuel tanks, floating around in orbit around the Earth, so that you send your rocket up, and now you're in your spacecraft, but your spacecraft is running on fumes. It's on E. And so you hook up with one of these fuel depots, you get a fresh batch of fuel, and then your BFR itself has a giant rocket attached to it that can buzz you around the solar system. It can get you to the moon. Maybe there's a fuel depot on the moon that gets you to Mars. Maybe there's a fuel depot on Mars that gets you to the asteroid belt. Maybe there's fuel depots in the asteroid belt. So this isn't a self-contained system. It's a staged system. It's a system designed with the expectation that there'll be these depots and staging posts. It's like the Pony Express of space, where you trade fuel tanks or you get new fuel as you go and push one level deeper out into space. That's not a horrible idea. To me, at least, it's not a horrible idea because it keeps things simple. It keeps things repeatable. It allows you to do a bunch of launches. It trades complexity. Instead of having one device that gets you anywhere you want, you just do a lot of simple things repeatedly. And if you can crack a simple thing once or twice, you can probably do it 100 or 200 times. So it's not that bad of an idea. Now, totally switching gears, the Space Cadets, another one, John Stiles asked about Titan, the moon of Saturn. This is one of the most fascinating objects in the solar system. And believe you me, there are a lot of fascinating objects in the solar system. Titan is up there. Titan is definitely up there as top 5. I'm going to go ahead and put myself out there. Top 5. One of the weirdest things in the solar system is this moon Titan, the moon of Saturn, the largest moon of Saturn. Way out there. And you expect the best thing about these moons of the outer worlds is that they're so far away from the sun. You expect them to be lifeless, frozen, dead, boring, like our moon. Our moon's super boring. I don't know why anyone would want to visit our moon. There isn't much to look at that you can't see from a telescope. Oh, another crater. Like, we've seen all the craters, okay? And then nothing interesting is going on the moon. But Titan is totally different. Titan looks more like the Earth than it does our moon. And I'll get into more details after the break. Don't forget to call 888-581-0708 to join the conversation, or join those Space Cadets on the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. And this is Space Radio, and this show is brought to you by you. That's right, you go to patreon.com/PMSutter. Your contributions every single month keep this show going. See you after the break. Titan as weather. Oh, I love Titan. I want to spend more time on Titan. Not personally, of course. Robotically. Welcome back, everyone. I'm Paul Starr, and this is Space Radio. I've already started answering a question. I've teased it. Now I am going to satisfy the tease, but you can join the conversation by calling 888-581-0708 or by following the live streams. Go to spaceradioshow.com for the link. So Titan, moon of Saturn. Titan has a thick atmosphere. Titan has lakes and streams and rivers. Titan has rain. but not of water. It's way too cold out there for water clouds, water rain, water rivers, water everywhere. Titan has a complete hydrological cycle, the exact same hydrological cycle we have here on Earth, except it's methane, except it's hydrocarbons. Think of walking up to a lake, and the lake is made of gasoline. Think of rain hitting your head. The rain is made of methane. What a strange place. The temperatures here are like 200 degrees below zero. So very, very, very cold. Water ice would freeze. And in fact, there's a crust of water ice making up the surface of Titan. And on top of that crust are these methane lakes, methane seas, methane clouds that condense and fall as rain and then evaporate. What a strange world. What a strange world. It's the big question we have about Titan. By the way, we have images from the surface of Titan. The Huygens probe that was attached to the Cassini spacecraft that spent a ton of time in orbit around Saturn actually fell to the surface, landed on the surface, snapped some pics, and then died. But it fulfilled its mission. We have images from the surface of this world. We want to know, like, is there life on Titan? You know, life as we know it requires water. Water is a solvent. Water is the solution in which all our chemicals do their things to make life. Is it possible to have an analog to that instead of using water to base your life on, use these hydrocarbons like methane? We honestly don't know. It seems dicey, but you know, life finds a way. So could there be life on Titan? I don't know. Probably not. I'm not getting my hopes up, but it would be super cool if we did. Now, I did get a voicemail. This past week, and even though we're not taking calls this week, I can play the voicemail. So here we go. The voicemail. I haven't even listened to it, but it is 82 seconds long.
Hi, Spaceman. This is Adam over in Irvine, California. My question is about the Drake equation, of course, going back to your last Ask Spaceman podcast. And regarding your rebuttals, I agree completely with you. However, I have to ask, what is it that we would use that's better than the Drake equation? And as far as the constraints or knowing what you don't know or the accuracy or error rate, I think that could be determined. Now, please understand I'm a lay person, but I believe that would be able to be determined by just assuming infinity and moving towards infinity with a little bit of calculus that I'm sure you could apply and come up with some sort of constraint on that to give you an idea. And you could apply that towards, the number of criteria that we apply it towards, as well as the number of possibilities. For example, how many planets have water? Well, we don't really know, so assume 1 to infinity and then kind of move the point along. That's really actually kind of a poor representation. How else could I describe this? And I probably should have written this up before I called. In any case, I'll keep it simple. What do we have that would be better, and how would you apply a constraint upon the unknowns? Thank you. Hi.
Excellent question, Adam. Thank you so much for that. And yeah, I did an episode on my podcast, Ask a Spaceman, all about the Drake equation, which is an equation that purports to be able to give you a handle of some sense. I'll put an estimate of how many intelligent species are out there that we could talk to. And I kind of did a takedown. I did take down the Drake equation. I'm not the biggest fan. This was my opinion, but my opinion based on my years of experience as a scientist. I don't see the utility in the Drake equation either as a scientific equation or as like a philosophical starting point for just sparking conversations. I think it gives the illusion of knowledge, and I dug in. So go to askaspaceman.com if you want to dig into that episode. And I feel like I'm going to be defending that episode for the rest of my life, which I'm okay with. I could be wrong. Again, that was an episode about my opinion. But what Adam is asking here is like this equation where you start with, okay, how many stars have planets? How many planets might have water? How many of those might give rise to life? How many of those give rise to intelligent life, and then intelligent life that starts talking on the radio, et cetera, et cetera. And we basically don't know any of those numbers, any of those fractions, any of those probabilities. And so Adam's asking, well, any one of those numbers is somewhere between 0 and infinity. Obviously greater than 0 because here we are, literally on the radio. And probably less than infinity or less than 1 because, not every star has an intelligent species around it. So is there any way, Adam's asking, is there any way to start constraining it? And yes, you can pick one of the terms in the Drake equation and subject it to scrutiny and try to measure it. But the end result, in order to measure that one parameter, like how many planets have liquid water, you're essentially going to have to do a survey of all the planets, of all the stars. And by the time you've done that to pin down one parameter, you've answered the entire question because you've done a survey of all the stars and all the planets, and you've already found out who's out there. So by studying one of the parameters, you study all of them. And so that's my approach. That's what I think is to ignore the Drake equation and just go looking for life. Just look for it, and we'll come up with how common life is by doing all the data, collecting all the data, doing all the science. Now, before I go at the end of this segment, I did get one more question over here from the Space Cadets from 0132-132 asking, going back to Titan, asking, would oxygen be explosive on Titan or is it too cold? Great question, because here on Earth, we have lots of oxygen in the atmosphere. It's just hanging out, minding its own business. We have lots of methane, like underground or in pipes or whatever. And when we get them together and add a little bit of heat, it starts a chain reaction where they combine, they release a little bit of heat, and then more can combine and release a little bit of heat. And the process continues until you run out of heat, or you run out of methane, or you run out of oxygen. Titan has lots of methane. Check. No oxygen, though. No oxygen, at least in a usable form. It's locked up in water that's frozen under the surface. So if you brought, this would be funny, on Earth, we have tanks of kerosene that we ignite, and the oxygen is already in the atmosphere. On Titan, the methane is already in the atmosphere, so you take a tank of oxygen, and you'd have an oxygen blowtorch. So, but it's so cold. It is 200 or whatever degrees below 0. It is so cold. Could you actually do anything interesting? Yes, you can sustain reactions, but you need a lot of fuel, a lot of oxygen. You're going to have to fight really, really hard to keep that flamethrower going on Titan. Asking the important questions. I don't know what you're up to, 0132-132, but I like it. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I love the mad scientist questions that you guys ask me. Like, if we were to blow up the moon, how bad would it be? If I were to try to blow up Titan, how hard would I have to work? O2 Blowtorch, there it is. Should that be the name of the episode? Oxygen Blowtorch? Sounds like a band name. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I'm not going to spam every single week talking about my book, even though you should totally buy my book, Your Place in the Universe by Prometheus Books, available on Amazon, Barnes & Noble, Books A Million, IndieBound, the whole deal, in stores November 20th. I wanted to make a special announcement here because I'm running a special, a very, very special. If you're a fan of Space Radio or Ask a Spaceman or any of my video series or whatever I do, I understand that autographed copies are a very attractive thing, where I write a little note, I write your name, and then I write your name, and then you have a copy of the book, and that means something to you. This is important to you. I'm okay. I'm on board with that idea. I can go with it. So I'm giving away free signed autographed copies of my book. But there is a catch. There is a catch. You know that patreon.com/pmsutter is how I support this show. Some of the money goes to WCBE to keep the show going. Other bits of the money go to support all of my education and outreach activities. This is a cornerstone of me being able to do all the awesome science communication that I do. That is awesome in my own words. I'll let you decide if it's really awesome or not, but either way, I'm doing it, and Patreon is how it's supported. So I'm running a special. If you sign up for my Patreon before the end of September, keywords, so like do it now. If you sign up before the end of September and contribute at least $10 a month, so there's different tiers, 1, 3, 5, 10, 25, 100. If you do that, and you go for 3 successive months. So you'll get charged on October 1st, on November 1st, and December 1st. You keep that up, $10, $10, $10, or $100, $100, $100, your choice. December 2nd, I'm sending you a free autographed copy of my book. That's right. I'm not even making money from this deal. You're basically paying for the book, which is like you're paying the normal cost for the hardcover book, and it's getting shipped to you for free, and I'll autograph for free. Just for signing up for Patreon for those 3 months. And if you want to quit after that, that's your business. That's your guilty conscience. I'm not going to judge. I have a lot of great supporters on Patreon. I'd like to thank 2 of my top ones who have earned a spot, a shout out on the radio, Robert R. and Matthew K. There are hundreds more that are supporting the show. It is my privilege and my honor to be able to serve you by communicating science and by you enabling me in a good way to talk about science. I truly appreciate it. And this is just one small way I can give back. So patreon.com/pmsutter. Sign up before the end of September. Do it now. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. That's right, patreon.com/pmsutter. Learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the space cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern, except when I'm having oral surgery. You can call 888-581-0708 to join me on the air. You can also catch the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. You can also follow me on social media at Paul Matt Sutter on all the channels. And thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End transmission. So I've got 2 questions for you, Space Cadets. 1, can you hear the cicada? There's like a cicada like right outside my door. That's been going on for like half the episode. 2, can you see me sweating? Because I had to turn off the room's air conditioner because it was too loud. And it quickly got really hot in here. Oh, Larry, you had the Amazon pre-order. Do it both, man. Do the Amazon pre-order and do the Patreon. You keep the autographed copy for yourself, and then you give someone the Amazon unautographed copy for a Christmas present. Do it, Larry. That's the way to do it. Don't buy 1 book when you can get 2 at twice the price. No bug noise you don't hear? Okay, that's good. It's driving me insane. Super distracting. Oh, you didn't know I wrote a book, Zero? Yeah, I wrote a book. Go to pmsutter.com/book. I'll put it in. There it is. All right. I'm running on battery, Space Cadets, which means I have to go. I'm almost out. I did not plan this well. It was kind of a last minute thing. I wasn't even planning on doing a show today just because I knew I was traveling, but I caught a moment, decided to set it up and do it. Thank you so much for watching. I won't see you next week. So next week, I'm going to try to live stream from the ship. I doubt it will go well because it will be in the middle of the Caribbean. If I can, you'll see me live. Otherwise, just go to spaceradioshow.com and you'll see the podcast version because I'll record